Very good. Thank you very much. I will switch directly to Pawel Wargocki from the Danish Technical University for the next presentations. We are a little bit behind schedule. I hope we can catch up. There's clearly a lot of interest, as can be seen from the questions. So, Pawel, the floor is yours.
Okay, thank you.
Perfect. Thank you.
Sorry, so you are insinuating that I should catch up with time, so I'll try to do that. I'll do it rather quickly. My presentation. Again, many thanks for invitation to this important presentation of the Renew School project, and many thanks to all the participants. I saw there's about more than 40 or 50 participants. It's really a beautiful turnout. So I will be speaking on one element of the Renew School, although I'll try to summarize some of the elements of the Renew School that have not been probably yet summarized in the beginning of in the two presentations from the very beginning. So there are main objective of this project was to disseminate the solutions for quick and robust energy retrofits of educational buildings. This is really an important task because there are many schools that require renovation, and they created completely different challenge than renovation of other buildings, like residential buildings or office buildings or other public buildings. Here we have very little time. We discussed this a lot. So this is one important objective of this project. The other is to promote using a facades for retrofit of the schools using wooden elements, and also using a prefabricated solutions. And I will not go very much into details about that. But last, and to me, because of my expertise or my interest, objective of this project is to look at the solutions that would not only promote the reduction of the energy use and support energy retrofits in educational buildings, but also that they will secure that when the retrofit schools will not aggravate or will not reduce the conditions for learning, because the schools are built and constructed mainly to create conditions that should facilitate learning and proper development of children. So learning is one part, but on the other hand, if we think about elementary schools, the children body and physiological systems are still developing, so they should not be at risk. So any of the retrofits should not, sort of like put it on or compromise the other important elements or objectives of the school buildings. So these are the 19 buildings that you will find on our web page of the Renew School, and these are educational buildings. Originally, we were aiming in having only schools. In the end, it was difficult to find only schools, so we have also kindergartens, but I don't think this is gonna be a problem. Also, originally we were aiming also in looking at the renovated schools and renovated buildings, but we have also the new builds, so included. So for us, it was kind of difficult to to find the frontrunners that meet a certain criteria, because there were certain criteria set up at the outset of the project, and those criteria are listed here. There's a timber facade, 66% reduction in energy use on primary energy, and 20% of energy demand covered by renewables, and IAQ was high level with special technological solutions. So it was difficult to find the buildings which actually already exist. They are maybe under construction, but still difficult to find the buildings that could actually fit into those kind of criteria that are strict that were developed. So, as I said, we displayed all the frontrunners. For each frontrunner, you can download the brochure on our webpage, read a lot of information, and the two type of information that you can find is, for example, energy. And if you look at the energy summary, you can see what are the sources, what are the renewables, what is the coverage of renewables in the total energy use, what is the total energy use for heating and total per square meter floor, in those buildings, what are the U values for walls and windows, and also for some of the buildings, some information exists on air tightness. So all this information can be found there, and we don't have time to go into details on that. Also, there is information about the system that are used to support indoor environmental quality. There is a lot of information about facades and achieving levels of daylighting, and I don't have time to talk about this. I will speak only about ventilation, which is usually associated with the creating the conditions that facilitate high indoor air quality. So there could be other methods for achieving high indoor air quality, but we don't have time to discuss this. If we look at the systems for ventilation, basically most of the schools, they have a balanced mechanical ventilation, mostly with or without the CO2 control. There was very little difference between those buildings. The only difference was that it was either the centralized systems or the centralized systems. The centralized systems are the systems that are installed actually per class. So each class is supported by one system. Central system is the system that actually is supporting the entire building, or the part of the building, or several classes, and then or classrooms. And then there have been sporadically hybrid ventilation systems installed. So the hybrid systems are the systems that use the natural sources and natural forces and mechanical forces to draw the air into the classrooms. They have been sporadically represented in that, and mainly for the spaces or for the assembly spaces, for the corridors, and so on, for the big halls. All were with heat recovery, because otherwise it would not be possible to meet the very, very strict heat requirement, and usually with heat and moisture recovery. So these were energy recovery systems rather than heat recovery systems. With energy recovery, efficiency was around 80–90%, as indicated by nominal numbers in the design. There were also other solutions that were installed in those buildings, and they included free cooling or night ventilation. So night ventilation is the system that is actually increasing ventilation during the night to use the natural cooling capacity of the air outside to reduce the temperature of the construction during the night. Some of them used low-emitting materials, but we did not have information on by which terms the low materials were actually, on which criteria they were, by which criteria they were termed low-emitting materials. And some of them use floor heating, one or two used adiabatic humidification, and so on, so on. And then for the lighting system, this is here on LED. I will just skip it. So basically, the project would like to answer what is a technical signpost for those front runners. So if we take the front runner buildings and say, okay, these are today, as of 2016, they represent the top of the top, I would say, or the front runners for the educational buildings. So what is what the elements, what they represent, how we can define those good elements, and how we can disseminate this information. So for the future, there's projects that you can take from the shelf, actually, the solution, and use it in a building, and be certain that the building will perform to the certain level. And also, what is it in which respect those buildings do not perform well? So these four elements, they include facade, ventilation, energy, and daylighting. But how we can do this if we want to investigate those winning concepts and technologies as regards technologies, should we do it by only looking at those technologies that are installed and look at the information that is available through the market information, or the information that is available online or in the different handbooks and so on, or rather that we try to actually measure the conditions, crude measurements, but still do some measurements to see how the buildings perform as regards indoor environmental quality. So this is what we try to do, and this was not originally planned in our project, because the project is basically a dissemination rather than generation of new information. But in the process of dissemination, we felt that it's very, very important to map the quality of the conditions in those schools and see how those schools perform as regards the indoor environmental quality. So what we did is we performed physical measurements and in selected front runners for those to which we could actually get an access, gain the access, because it was not agreed from the very beginning that the front runners should also allow us to get in and make the measurements there. And also in some of them, and I will not present those results here, I can share the paper that is actually presenting them. We also distributed a questionnaire to ask the pupils and the teachers about their perceptions of indoor environmental quality in those buildings. But of course, looking only on the front-runner buildings may create a biased, perspective and biased picture. So we also selected few conventional buildings, the buildings that could not be categorized as the front runners, and we performed the measurements there as well. We selected one class or one playroom per school or kindergarten. It was third to fifth grade, and we performed the measurements during the heating season of 2015 for 2 months in continuous measurements. Well, these are the front runner buildings that were selected for that. And then what we did is this is a very, very crude measurement, and it's just to map the conditions. So what we do is we use the measuring stations as actually shown here on this slide, which included the CO2 monitor and a logger with built-in sensors for temperature, relative humidity, and light levels. And they were sent by post to the janitors. And deployed by the janitors. They were informed how they should deploy those measuring stations in the classrooms, or basically they were deployed by the project staff. So let us have a look at the results. These are the results. On the left hand, you see the green bars. On the right hand, you see the red bars. The green bars are, front runner buildings, green buildings, and the red is. It's not that I want to, condemn those buildings, but it's just to differentiate the two types of buildings. So what we see here, these are average carbon dioxide levels for the period of measurements, and except for one kindergarten, all of the front runner buildings perform better as regards the average CO2 levels, which were on average about 200 to 300 ppm lower than for the for their counterparts, which cannot be classified as the front runners. You can see they were on average lower than about 1200 ppm. Most of them average levels in 1000 ppm, which is usually used, many far below 1000. So if we try to make a very, very crude estimate, what would this correspond to in terms of ventilation rates? So those front-runner buildings would have about 3 to 4 liters per second per person higher ventilation rate, outdoor air supply rate. So so best CO2 performing front runners were the buildings which were new construction. But as you will see here, the 4 dots. They used either the central balanced mechanical ventilation or decentralized system, so they all used mechanical ventilation. We don't have any information, unfortunately, about the systems which did not have mechanical system. Less well CO2, actually, if you look at the front runners, because we also wanted to know, is there any schools that perform less well or front runner buildings? Well, I mean, it's again no big difference. Again, we have a mechanical system. Maybe more on the renovated rather than new construction. But I mean, it's by accident that it's occurring like that. So if we look at the temperature, we don't have time to discuss more. we look here that there is no big difference between the Frontrunner buildings and their counterparts, which cannot be classified as Frontrunners. And the average temperatures are from about 22 to 25, never exceeding on average 26 during the period of measurement. However, what we see here is that they are on the higher side of, I would say, the thermal comfort continuum. So they are above 22 degrees in the upper levels of temperature, so 22, 23, 24, up to the 25. And then if you would estimate a PMV, particular mean vote, that would be neutral to slightly warm, with the dissatisfaction level was about 15%. So they do not perform differently from the buildings that are already in use, which are not renovated and not Frontrunners, and they basically are on the warmer side. We would really like to see maybe the distribution around the 22 degrees or something like that. So they are on the warmer side, but never exceeding 26. So, in concluding, because the time is running, I was supposed to catch up. So it's not possible to associate any particular technical solution applied in Frontrunner buildings with the actual indoor environmental conditions. The CO2 measures are below 1300 ppm temperatures. Temperature fluctuations in Frontrunner buildings are actually low, and temperatures are on the slightly higher side. So the good news for the measurements that we perform, the crude measurements, is that the energy retrofits of educational buildings do not aggravate the conditions. I mean, do not make the buildings worse than they are now. But at the same time, we cannot see that they improve significantly the conditions. So they just keep the status quo, I would say. We have to remember that those measurements have certain limitations. We have non-representative selection of Frontrunner buildings. These are new constructions, not only retrofits. This is only a measurement in a subset of Frontrunners, and so on, so on. So there is a certain limitations, but at least these are few measurements that are available for the buildings that underwent the energy retrofit. There are very few measurements of that type in that type of buildings available in the literature. So which way to go? So based on those Frontrunners that we have, our technical signpost would be balanced central or decentral mechanical ventilation with energy recovery and CO2 control. It's nothing new, it's nothing special, but at least this is the technological development as for today. It would perform well, but whether we could create a significant advancements to IEQ or IAQ with that solution is to be debatable. So maybe we need to continue developing other solutions. So this is my presentation. I want to acknowledge the European Commission for supporting us, and thank you very much for your attention. And if you have any questions that they come up after, pop up after the webinar, please send them to me. I'll be happy to answer them by email. Thanks a lot.